Okay, so if you guys noticed, I'm going to kind of skip through the most of the work for part A, because for part A, if you don't have that curve memorized, what you can do is you can draw out the unit circle and then make a t-table like I do. And you can see that 1 minus cosine theta, that's a cardioid, right? It's like a kind of like a heart type of thing. So in this case, it does look something like that. And you should notice that that's going to be the trend. You can just use the symmetry for you can just use all of these points, using all of these, and then the same thing over here, and then draw the other half. It should look better than this when you do it, but this is our shape, okay? And what we want to find is the length around the curve, so the arc length, I guess, kind of, just really the length of the curve. We want to find the area inside here, okay? So, I'll write, okay. And what I'm going to do is I'm going to show you guys my notes and show you guys the formulas that we're going to use to find the two things we need. There we go. The area for a polar region, we'll use this formula right here. It's the same thing as this one as well. But we're specifically going to use this one right here for the length. You can, by the way, these are all equal. That's why they're saying they're all equal. But these are the two integral formulas we will use. I just wanted to give you guys some legitimacy. So, say area is equal to 1/2 integral b to a, r squared d theta. Okay, so 1/2 integral b to a, and r squared is 1 minus cosine. 1 minus cosine theta squared d theta. Okay, now what is b to a? So the area, right, we want to find the area. So area of this whole thing. What we can do is instead of going, b to a is 0 to 2 pi, but, so I'll write that there, 0 to 2 pi. So this is the same integral. What we usually want to do is use symmetry, just so you don't have to do as much work. And it's the exact same thing. 1 minus cosine squared theta d theta. So this is that integral. And we'll do it. Okay, so 1 minus cosine theta. We could factor. I think it's just easiest if we factor instead of trying to do some sort of tricks. So 1 minus cosine theta squared is equal to 1, right? 1 minus, and then it's going to be a negative cosine theta plus another negative cosine theta, so 2 cosine theta. And then there's going to be 2 negative cosine thetas times each other, so plus cosine squared theta. So then so we have 3 integrals here. Well, pi to 0. Well, actually, we can just write 2. 1 minus 2 cosine theta d theta, and then a plus pi to 0 cosine squared 2 theta d theta. And this first integral we can do, and we know that will just become, this will just be the first one. So it's going to be pi minus 2 sine theta, and then that sine theta. Sorry, one sec, I kind of skipped a step on you guys. I won't do that. Divided from pi to 0. There you go. I shouldn't skip steps on you guys. Plus this other integral. Now, since it's cosine squared, we got to rewrite it, and we can rewrite it using the half angle identity. So that's 1 plus cosine 2 theta. Now, I did have that one memorized. That's the half angle formula for cosine squared. Okay, so let's actually do this thing first. That's going to become pi minus, and sine of pi 0, sine of 0 is 0, so it's just pi minus 0. Okay, that's that. Next one, 1/2, and this is going to become theta plus sine 2 theta divided by 2, value from pi to 0. Again, the pi in the front, we already evaluated that, so then we just have 1/2, And now we got to put pi and 0 into this, so that'll become pi. And then if you put pi into here, sine 2 pi is 0, so that doesn't really do anything. If you put 0 into here, theta 0, then this would be 0 again, just pi. So it's pi plus 1/2 pi, which is 3 pi over 2. That's the area. Okay, this next integral, what are we going to do? Well, let's actually write out the integral. So we want to find the length integral. Again, it's b to a, and I showed you guys the formula earlier. It's r squared plus dr d theta squared d theta. Now, guys, these formulas, they don't come out of nowhere. You can derive them, you can practice deriving them. And generally, once you know the arc length formula, you can find all the other arc length formulas for any sort of situation. But it doesn't hurt to write them all down. Okay, so this is what we have. Now we already know what the r squared turns into, right? This is r squared and it turns into this. So I'm going to jump a second here. And I just want to worry about the integrand. So we have r squared plus dr d theta. Now what is the derivative of this? If we take the derivative of this guy, it's just sine theta. Okay, so then r squared, remember, right, r squared is the same thing as this guy. 1 minus 2 cosine theta plus cosine squared theta plus sine squared theta. So you can see what happens is that cosine squared and the sine squared turn into 1, and then we get 1 plus 1, which is 2. So we get 2 minus 2 cosine theta. Well, that is that, right? Okay, so now we can use that and say the length is equal to, and remember, we start at 0 and we go all the way around. So if you go all the way around everything, that's 0 to 2 pi, right? And this is 2 minus 2 cosine theta d theta. And then I gotta make more space, because this integral will take a little bit more space now. Okay, so I realized maybe I went about the first integral a little bit inefficiency, and there was a very nice substitution. Not substitution. Well, yeah, it is a substitution. There was a very nice thing you could have done that would have made it maybe a little bit easier. But if you don't remember all these formulas, I mean I remember these formulas, but I usually don't think of them as their counterpart like this. But here you go. You could think of these as this, and we'll use this to do the other integral. So just using this, let's go ahead. Sine theta over 2 is equal to plus or minus 1 minus cosine theta over 2. That's all we're going to use to do the next integral. So sine theta over 2 is equal to plus or minus square root, and now I already forgot it, 1 minus cosine theta 2. Yes. A lot of times in math you can't remember all the formulas, but you can go about doing things maybe a harder method if you don't remember. So remembering saves you time, but you can't remember everything. Okay, for this formula what we want to do is derive it into a form that looks like this. Okay, so what it means is let's get rid of the square root. Right? Why? Because I just want to. So sine theta over 2, this becomes sine theta over 2 squared, and then we get 1 minus cosine theta over 2. Okay, and then I'm going to times out by the 2 here, times by 2. So now I got 2 sine squared theta over 2 is equal to 1 minus cosine theta. And as you guys can guess, what if I times everything by 2? Because this is 2 minus 2. And then what if I square root everything? I know I kind of got rid of the square root a little bit earlier, but that's just because I'd like to do algebra a little bit in a way that makes it more familiar to myself. Okay, so if I'm times everything by 2, then I'm going to square root everything to get this exactly. So this becomes 4 sine squared theta over 2 square root, and then this is going to be 2 minus 2 cosine theta square root. There we go. So this thing is equal to this thing, and there we go. We can replace it in our integram. So I'm going to do it over here. So we got the length is equal to 2 pi to 0, and we got 4 sine squared theta over 2 square root d theta. And yes, as you guys can see, there is perfect squares in here, so they can't just come out of the square root. So we get 2 pi to 0, and then it becomes 2 sine theta over 2 d theta. And what does this become? Well, this becomes what? Well, we can factor out the 2, and then the sine theta, that's going to become a negative cosine, right? I'll put the negative out there, so we've got cosine theta over 2 divided by 2. Well, actually, not divided by 2. If this was 2 theta here, then it would be divided by 2, but it's theta over 2, so then it's actually 1/2. Okay. Oh, there we go. So I'm going to simplify everything here. Okay, remember how integrals work with like a chain, right? That little chain is like the opposite from the derivative. Okay, so -2, right? There's a -2 on the outside, and there's 1/2. That's going to come up top. So now we're going to get -4 cosine theta over 2. Why is my computer not loading it? And this is being bounded from 2 pi to 0. And this is going to equal to -4. Now, if we put cosine 2 pi in there, what happens? Well, 2 pi divided by 2 is just pi, so then we just get cosine pi. If we put a 0 in there, then we just get cosine 0. Okay, that's what we get. And then you can see that that's going to be -4 times -1 minus 1, which is what? That's -1 times oh god, my computer's not loading anything here. Sorry, that's really frustrating. Okay, so this is -2 times -4, which is 8. There you go. That's the perimeter of this cardioid. And over here is the area of this cardioid. And yeah, there we go. Okay, so this next problem, yeah, kind of similar to the last one I did. So we know what the shape r equals 1 looks like. That's just a circle. And we know what r equals 1 minus cosine theta looks like because we saw it from last time. So I'll draw it. That, and then we'll do r equals 1 with the green circle. Okay, that's what it looks like. That's our shape. And we want to find the area of the region that lies inside the circle and outside the cardioid. So yeah, I'll use this color. So everything right here. I'll try to make sure I shade this thing nice because for some reason I'm trying really hard to shade it. Okay, that's the region we want to find, but we need to think a little bit about how to describe this region. So we have 2 points that are touching. So with those 2 points, it's kind of important to see what that means. So that's where r equals 1 and r equals 1 minus cosine meet. So r equals r. So 1 minus cosine theta is equal to 1. In other words, if you drag this out, then you can see that 1 is equal to 1 minus cosine theta. So basically 0 is equal to cosine theta. So you ask where's theta equal to 0? Well, then we said theta is equal to, in this case, we'll call negative pi over 2 and pi over 2. That's what satisfies this. And by the way, negative pi over 2, you could also call that 3 pi over 2, whatever you want to do. I mean, you call it negative pi over 2 for this case. So there we go. And now note that we could do this one way, but I think this way is a little bit easier what I'm about to do. So we say we have the area that we want to find, we'll call it just A. But then we have the area of what? Well, we have, let me just do this. We have the area of the circle minus the area of the cardioid. Circle. Okay. So the area of the circle, we know exactly what that is equal to. That is pi r squared. And then we're going to minus out the area of the cardioid, which is what? It's going to be from pi over 2 to negative pi over 2. And note that it's only half, right? It's only half of the circle, really. If you get what I'm saying, right? Because like we're bounded right here. So we'll divide this guy by 2. And the area for this, remember, we did, maybe you didn't remember or see the first video, but we said area is equal to 1/2 r squared d theta beta a. So I already kind of inserted things here. I have 1/2 here. My bad, my head's blocking it. Here, this is the form that I was using. I should have said it earlier. And the r squared is 1 minus cosine theta squared d theta. So there's another way to do this. I mean, like, this is the easiest way just because this one, we have a circle here. But, you know, realistically, what you usually do is you have one integral, or you could always write it as 2 integrals because of the linearity principle. But generally, you have one integral and one region minus the other region. And this is the exact same thing. There's no reason to use an integral to compute a circle because you know the area for a circle, right? We know that by heart. Okay, so r is equal to 1 for this case, right? So it's just going to become pi over 2. That's it. And we have minus 1/2. And we got 1 minus cosine theta. Theta pi over 2. So negative pi over 2. So what I could do is I could get rid of this negative 1/2. I mean, get rid of this negative pi over 2 by timesing this whole guy by 2 using the symmetry. So I'm going to erase that guy, and erase this guy, and put a 0. That's just symmetry at play. So this is the area. And then I will actually have to compute this guy, though. But I will show you guys the identity that we'll use. Okay, I kind of lied. Instead of using identity, you could just factor it. It's just, I mean, just do the factoring here. So the 1 minus cosine theta squared is going to turn into 1 minus 2 cosine theta plus cosine squared theta. If you don't trust me, you can do it yourself. Okay, so that's our new integrand. And I'll just write out. So then we get 1 minus 2 cosine theta pi over 2 to 0 d theta plus the cosine squared integral. And now cosine squared itself, you can write it as this. 1/2, then 1 plus cosine 2 theta divided by 2. So now, there you go. And delete that guy. Yeah, it's, if you factor out the 1, it's 1 plus cosine 2 theta. So this is, sorry, a little minor mistake. I corrected it though. So pi over 2 to 0, and 1 plus cosine 2 theta d theta. So what's this equal? This becomes theta minus 2 sine theta plus 1/2 theta plus sine 2 theta over 2. And all of this is being evaluated from pi over 2 to 0. So what does that become? We'll find out. Okay, so you put pi over 2 into here. Let's see what happens when you put pi over 2 into everywhere. So we'll get pi over 2 minus sine of pi over 2 is 1, so we get 2 and plus 1/2 and pi over 2. Now sine 2 theta, replace the theta with the pi over 2. That's 2 times pi over 2. Then sine of pi is 0. So plus 0. Now minus, what happens when we put 0 into everything? Well, then we get 0 minus 0 plus 0. Yeah, if I didn't do anything wrong, there we go. What does this become? This becomes pi over 2 minus 2 plus pi over 4, which is equal to what? Well, that's going to be pi over 4 plus 2 pi over 4, which is 3 pi over 4, minus 2. Okay. Now, remember, we had, like, this guy right here was replaced with this guy. Well, basically, this guy itself was replaced with this. And since this guy was replaced with this, and this thing equals this, and that guy, we found it really fast, right? So our final answer for the area is just this. It's pi over 2 minus 3 pi over 4 minus 2. And we could write that as what? So I'll write everything under 4. Okay, so then that's going to become what? It's going to become 2 pi, right? Times that by 2. Yep, that's correct. Wait, 1 second. If we times everything by, we want 4s are common denominators, so 2, 2. Okay, and minus 3 pi. Timesing everything by 4, so there's 1. This will become now 8. This is going to be negative pi minus 8 over 4, which makes absolutely no sense, so we did something wrong. Okay, I spotted the error. Good thing I caught it. Parenthesis. Kind of a big deal. So if we use that parenthesis, the factoring, now it makes more logical sense, and this is our answer. So we get 8 minus pi over 4. And if you want to see it maybe a different way, you could write it as 2 minus pi over 4, which is literally the same thing. Just either or. Maybe I like this one a little bit more, so we'll leave it there.